Hello pre-calc students, I'm starting quiz 1 on vectors. So our first question is asking whether vectors u and w are equivalent. So let's look at vectors u and vectors w. Vector u, notice the vectors are going to start where there's not an arrow and end where there isn't an arrow. So vector u, if I see this is the starting point, this ending point, is going to have a horizontal component of -2 and a vertical component of 1, 2, 3, 4, -4. So that's for vector u. For vector w, we'll have a horizontal component of 3 and a vertical component of 1, 2, 3, 4, 5, 6. A vertical component of 6. And so these vectors don't have the same horizontal and vertical component, so therefore they are not equivalent. So let's check this out. They have different magnitudes and directions because their magnitudes are different and their directions are different. So we got that one right. Let's move on to the next question. We need to find the magnitude of vector u. All right. So if this is the horizontal component and this is the vertical component, 2 is the horizontal component, -4 is the vertical component. We can find the magnitude of the vector. In fact, we can draw it. We start here. Our horizontal component will be -2, or will be +2. Our vertical component will be -4. And so our vector will be that magnitude. And we can find the magnitude, hopefully you can see it by using the Pythagorean theorem. So the magnitude of vector u, that's going to be equal to the square root of 2 squared plus -4 squared, which is going to be equal to the square root of 4 plus 16, which is equal to the square root of 20. So that's the square root of 20. So what? You can answer the expression as a square root symbol, and because of that, I'm just going to put in the square root of 20, and hopefully that will be the right answer. It is. Excellent. Next question. Clearing annotations. Vector w has an initial point 6, -3, and a terminal point of -7, 8. Find the components of vector w. So let's plot our initial point, which we're going to arbitrarily label as 6, -3. This point has an x value of this point will have an x value of 6 and a y value of -3. The next point in the vector, that's the initial point. The terminal point is going to be at -7, 8. So I'm going to go left 7 and up 8. So this point will have coordinates at -7, +8. So to find the component form of the vector, so what the vector will look like, and to find out how much over to the left I go and how much over to the right I go. So to find my horizontal component, I can do, I can see I'm moving left. So I would do -7. This value would be -7 minus 6, which is going to be equal to -13. So I have a horizontal component of negative 13. And then my vertical component is going to be 8 minus negative 3. So this vertical component right here is going to be 8 minus negative 3, which is going to be equal to positive 11. And so my vertical component is 11, and let's see if I'm correct. We are, so let's move on to the next question. Are vectors u and w equivalent? All right, so our 4 answer choices are they are equivalent, and then B, C, and D say they're not equivalent but for different reasons. No, they have different magnitudes and directions. No, they have the same direction but different magnitudes. Or no, they have the same magnitude but different directions. And I'm going to say for this one that they have the same direction and different magnitudes. Here's why. Both of these vectors are facing the same direction. This vector W has a horizontal component of 1, 2, 3, 4, negative 4, and a vertical component of 1, 2, 3, positive 3. Well, vector U has a horizontal component of 1, 2, 3, 4, 5, 6, 7, 8, and a vertical component of 1, 2, 3, 4, 5, 6. So 6 and negative 8. So if I was to find the slope, all right, the magnitude, right, the slope here would be, rise over run. 6 over negative 8, that's going to be equivalent to 3 over negative 4, right? So the direction is going to be the same, but the magnitude is going to be different because the components are different. So, that being said, they have the same direction, but different magnitudes. Clearing annotations. Which of the following vectors have the same y component as vector A? So, vector A has a y component, ignoring our horizontal component, but just a vertical or y component of 1, 2, 3, plus 3. So remember, we're starting at our initial point and ending at a terminal point. So this vector has a 1, 2, 3, a vertical component of minus 3, which is not equal to plus 3, so we can cancel out vector C. 1, 2, 3. That's a vertical component of minus 3, so we can cross out vector B. But for vector D, we do have a vertical component of 1, 2, 3, which is plus 3, which is the same vertical component as vector A. So vector D is the same vertical component as vector A. So only vector D has the same vertical component as vector A. Great. That's a quiz 1 for vectors. Clearing annotations.